In this lesson, we're going to use our properties of logarithms to solve equations that are a little bit more complicated. So we're going to start with a chemistry problem from our previous module. Here I've set the equation up for you, so I don't really want you to worry about how I set this up, although I bet if you've read the text, you probably understand how I've set it up here. And the goal here is just to think about, how do I isolate x? And there's a lot going on here, right? So we have this log of this number, and then the log of x is being subtracted from that number. So to get back to x, we're going to use inverse operations. But before we think about that, we're going to think about condensing our logarithms here. So I'm going to start, I notice I have a negative and a negative here. I'm going to start just by factoring that out because I think that's going to make my life a little bit easier. And then notice I can condense my logarithms here. So I have a sum of two logarithms that ends up being the log of a product on the inside. And then I'm going to divide by -1 just because, again, I think that's going to make my life a little bit easier. And now I'm at this stage where I have just a single logarithm. And now I'm going to raise both sides to the power of 10. So I've condensed my logarithm and I have it isolated. Now I want to do the inverse operation. Remember, this is log base 10. So the opposite would be exponentiating to the 10th on both sides, right? And what I get is we will have 0.158x is equal to 10 to the -4.1. And then obviously I would divide both sides by that 0.1585, and there would be my solution. So notice I didn't reach for my calculator until now, and if I want to, I can use my fraction function and just type it in exactly how it appears, right? So I can be like 10 to the -4.1 over 0.158, and it was a 5x, right? And I get this very small number. And what this means is this e to the -4 is it means multiply times 10 to the -4. So I moved my decimal point over 4 spots, right? So that would be, we'll say 5, 0, 1, 1, and then we were here 1, 2, 3, 4. So that's my value of x. And so it's a very small number that I got here. And then we were asked to find the pH of each substance, right? So, well, substance A would be negative log of 0.1585, which I can just type in like this. I get 0.8, we'll round that to. And then substance B would be negative log of x, right? Which would be negative log of 0.0005011. And I'm going to actually use the value from my calculator. I'm going to do negative log and copy and paste, right? And I get 3.3. So these are my pHs, right? Which I was asked for. Most of the lesson is actually going to be about solving for x, but I thought it would be nice to bring back this context from the previous lesson. So if we recall, like our context from the previous lesson, what we just figured out is we are talking about battery acid here and orange juice. So the sum of those is obviously 4.1. So that's the types of questions we can answer here. We're going to do 2 more examples just so we're clear about how the algebra works, although I think if you followed this, you're going to be in really good shape for the lesson. The key here, and I'm going to do both of these steps first before I work to isolate my variable. The key here for these is just to make sure you have one side as a single logarithm. So obviously here I'm going to subtract 5 on both sides. And then I'm going to divide by 2. Notice I can't do anything with the inside of that logarithm. It's sort of trapped by the order of operations here. I'm going to isolate that first. And then same thing over here. I'm going to start by condensing my logarithm. So I have a difference of logs. That means I have a quotient on the inside. And then I have a single logarithm isolated. From there, I can use an inverse operation. So what that will look like, right, is I will raise both sides to the power of e because natural log is the opposite of e. And then I will just be left with 6x minus 3 equals e to the 5th power. And that is a number. I don't need to know really what that number is. I just need to treat it like a number. What I'm going to do is I'm going to isolate x, keeping in mind that this is a constant over here. So I'm going to add 3 to both sides, and that would look like this, right? And then if this was a number, I would type it into my calculator and condense it, right? But that's going to give me a decimal that I want to avoid, so I'm just going to divide both sides by 6. I'm going to leave my answer in terms of e. So if I wanted to, I could type that whole thing into my calculator and get a decimal. But more often, we're just going to leave our answer kind of unsimplified like this because it's more precise. I don't have to think about rounding or anything like that. Okay, down here, same thing, right? We want to isolate our x, which means the opposite of the log base 4 is raise both sides to a power of 4. So we're going to get 2x over 6 is equal to 4. And then that's a baby equation. I'm just going to treat this as 2 separate fractions. I'm going to be like times 6 on both sides is 4, and then divided by 2 is 12. All right, so there is my solution here. Okay, so notice like the move here is to use our various moves, so inverse operations, combining like terms, the properties of our logarithms, whatever, right, to rewrite the whole equation with a single log on a side, right? That's what we did here. And then we use an exponent to undo the log. And that's what we did here, raising both sides to a power of 4, or raising both sides to a power of e. And that allows us to isolate that variable on the inside.